This is the solution to chapter 11, question 5. So in question 5, this chapter talked about limit pricing. And the question gives you a monopolist with the demand curve that is price equal to 390 minus 2Q. Marginal cost for the monopolist is exactly equal to average cost, which is $30. Part A, asking you to find profit maximizing price output of this monopolist. So you should all know how to do this by now. Find the marginal revenue for this monopolist, set it equal to marginal cost, which is $30. This should give you quantity equal to 360 over 4, which is 90. Plug this back into the demand curve. Price equal to 390 minus 2 times quantity, which is 90. 390 minus 180, so you have price equal to 210. Quantity 90, price 210. So profits would be price minus average cost multiplied by quantity. 210 minus 30 multiplied by 90, which is $16,200. So that is part A. Part B, you have a potential entrance is considering entering, but the monopolist has the cost advantage. Marginal cost for potential entrance is 40. So giving that potential entrance cost and average cost is $40. What will this potential entrance produce? Now you have to solve for the residual demand curve. The original demand curve is 390 as the intercept there, y-intercept 390 and x-intercept 390 as well. So on the quantity axis, the slope is, actually the slope is 2, so this has to be 390 and half of 390, which is 195. And because the monopolist is producing 90, so take 90 out. If the monopolist is producing 90, it will charge 210. What is left here, this part, from 210 all the way down here, is the residual demand curve. That the potential entrance is facing. So it's price equal to 10. The slope is 195 minus 90. So it is 2Q, which is, this distance is 195 minus 90, so 105, which is half of 210. So 2Q, and this one will be potential entrance, PE. Once you have that, find the marginal revenue of the potential entrance. 210 minus 4Q PE equal to 40. So for that, you should get Q potential entrance equal to 170 over 4, which is 42.5. And then you can solve for the total quantity. Part C asks for potential entrance, output, price, and profits, and the new monopolist profit. So this is actually part C. This is part B. Part C, we have quantity now, and quantity of potential entrance plus quantity of the monopolist will be a total amount produced in this industry. So it's 90 plus 42.5, which is 132.5. Price 390 minus 2 multiplied by 132.5, it is going to be 125. So the new price is 125. New quantity 132.3. Let's find profit for the monopolist. 125 minus 30 multiplied by 90, it is 8550. For the potential entrance, 125 minus 40, because it has a higher marginal cost, multiplied by 42.50, so 3612.5. Now part D, as for limit pricing. Limit pricing is price that will deter entry. So limit pricing has to be set equal to the marginal cost of the potential entrance, which is $40. At this price, there's no economic profit, so the potential entrance is not going to enter. Price for this particular market with the limit pricings 390 minus 2Q equal to 40, so you can solve for the entire market. QM is 100, let's see, 350 divided by 2, so 175. So the monopolist now is producing a lot instead of 90 units, because the limit pricing is very low at $40. So price equal to 40, producing 175. Potential entrants will not enter. Profit for the monopolist will be price minus average cost multiplied by quantity. Price is 40, cost for the monopolist 30, multiplied by 175, so it's 1750 only. We'll put this up in an extensive form of the game, or the tree form. This is question 6 now. So we have potential entrants who will decide either to enter or to stay out. When he enters, the monopolist will decide whether to charge the monopolist price, the high price, or limit pricing, which is a lower price that can deter entry. So we will charge high price or limit pricing. If it charge higher price and no entrance, actually let's put this one out. This one is stay out. So this is the first case that we solve in part A. Monopolist price, the entrance doesn't enter, so that's the first case scenario. And then if it use limit pricing, the entrance will not enter, but the monopolist profit suffer, goes all the way down to 1750. If the entrance enter, the monopolist have to solve for its profit when it's produced only 90 units, so it will be 3612.5. The monopolist stay put, did not change the production, but the market got stolen a little bit by the potential entrance. If the potential entrance enters and the monopolist use limit pricing, the potential entrants will not make any profit. So it is 1750. Now you solve the game with backward induction. With the monopolist, for the top branch, it will choose the monopoly price. For the lower branch, it will choose monopoly price again. And the potential entrants know that this game is complete, perfect information. So potential entrants will look at the two numbers in the front here, 0 and 3,612 and 50 cents, so we'll decide to enter. So using subgame perfect Nash equilibrium, basically you solve for solution of each subgame Nash equilibrium. We will have the situation where the potential entrants will enter and the monopolist will basically choose the monopolist price. So price will be equal to 100, 200 and it will produce quantity equal to 90. Okay, so we'll put use quantity equal to 90 and try to maximize its profit and stick to this solution from part A without changing. So let's change this into QM so it doesn't confuse you, which it will produce monopoly quantity. And that's why critics of limit pricing say that using the game or extensive form of this game, limit pricing will never work because it's not the solution, it's not a Nash equilibrium. Every time that the potential entrants enter, the monopolist will always going to not using limit pricing. It will never use limit pricing. In reality though, we found that firms do use limit pricing in order to deter entrants. You can read those cases in the book yourself.